I'll start from this side, and then we can go. Hey guys, Jags Kandasamy, founder CEO of Latent AI. We are a tool technology company that help AI developers bring their deep learning models to the edge. For us, edge is, as Jason was talking earlier today about the continuum, right? For us, we start with the sensor, we go all the way into the service provider edge on the CDNs and the telco as well, right? Shastri, you want to go next?
Sure, I'll go next. Hi, this is Shastri Maladi, co-founder and CTO of Foghorn. We are based out of here, California, Silicon Valley. We are a leading provider of edge AI platform and few of the packaged out-of-the-box solutions. I'm sure we'll get into more details on some of those killer apps and solutions. But fundamentally, we're about processing and doing machine learning, optimizing those, running AI at the edge. I know the definition might differ from person to person. We're talking about anywhere that's closer to the asset where the data is produced is what we're talking about. We do serve lots of Fortune 500 customers with these different solutions. We've been around for 5+ years in the market. Goran?
Okay, so I'm Göran Appelqvist, CTO of Crosser out of Stockholm, Sweden. I think we got a pretty good introduction by Shastri. We also provide an edge streaming analytics solution where we try to simplify as much as possible collection and analysis of data close to the assets, which in our case primarily is machines and different types of assets producing data. So any type of analysis of data close to the source, including deployment of AI models at the edge.
Okay, hi everyone. My name is Saurabh Mishra. I lead the product management team for IoT within SAS. SAS is the largest privately held software company and a leader in advanced analytics and AI. And we bring the same leadership to IoT. So we are all about enabling edge to cloud AI lifecycle that drive a number of use cases across a variety of verticals. And I think the panelists have talked about the definition of edge AI. I think that's generally consistent. We are essentially looking to take analytics to wherever the data is, right? In the past, traditionally, the idea was that you bring the data, you kind of prepare data in these large data lakes, data warehouses. But I think given the size and the variety of data, that's just not possible anymore. So we are looking to position data or rather analytics wherever the data is. So edge for us is anywhere close to the data producer. That could be the asset, that could be a server on a retail store, on a manufacturing plant, on a car. So it's just open to interpretation at some level based on the use case and the vertical setting.
Excellent. Awesome. Philippe, are you there? I see you online.
It's coming, going, and maybe you're still having...
Hello, can you hear me?
The panel. Yes, wow. Philippe.
Great. So I won't be able to use the video. I'm so sorry about that. But I mean, at least I'm there with you. So very quickly, my name is Philippe Caz. I'm the CEO of Topio Networks. We are a market research firm focused on digital transformation. We are tracking all technology associated with that massive movement of digital transformation. So edge computing, artificial intelligence, blockchain, you name it, 5G. And also all the applications that are going to take advantage of those new emerging technologies. And so the thing that is different about us is we provide that research for free on topionetworks.com. We have about 1.2 million users right now. And we are also organizing events. Our landmark event is Edge Computing World, which is the biggest event in the world in edge computing. And it's going to happen in October. So, very excited to talk about Edge AI. We had a great session earlier on around the business aspect of Edge AI, and now we're drilling down on the technology side. And so the first question I wanted to ask was for Saurabh. And, obviously, you have an application that is working, very well in the cloud. So the question is, why you're going through the edge, and then what are the problems that you're seeing going from a cloud application to a combined cloud and edge application?
Sure, Felipe. So great to hear from you. So why go to the edge, right? I mean, I think there's some obvious driving factors for going to the edge, especially with the type of IoT data that we're talking about. That data is not coming to the cloud. Some of that data will never come to the cloud, right? So in order to really benefit from that data, you got to be able to take processing, AI, and analytics to the edge, right? So that's kind of what the definition that we've been talking about. I mean, why do we need to do that? Is because some of this data is just really short-lived, and if we are able to harness this data, I mean, there is some valuable insights that you can gain from the data about your process, about your asset. So latency is really important, right? So you just don't have the time to like bring this data, do a round trip to the cloud, process it, and then get a result down. So being able to just kind of mine this vast amount of data, you have to be operating at the edge. Latency is another factor that you got to be at the edge so that you can respond in near real time. There's a number of other supporting driving factors as well. I think security is another factor, right? So the more data back and forth you're doing, the broader the attack surface is for some sort of a compromise. In some ways, you're kind of localizing the data and the associated processing, and you're only sending, let's say, the key events or the key alerts from this back to the cloud. So those are, I think, the driving factors that we consistently see. I think there's a lot of challenges when you start going to the edge and you start scaling at the edge. Unlike the cloud, where you have a known consistent environment, edge is fragmented, right? I mean, there is no single definition of edge, either in terms of like this compute environment is edge, and even when you land on a compute environment, there's a number of options in terms of providers. So that fragmentation is a challenge. Data acquisition remains a huge challenge, right, in terms of going to the edge, because you're not talking about, you're entering the territory of these assets and plants where data has been traditionally siloed in proprietary systems. So to be able to unlock and get data out is really hard. And at some level, I think that defines the success of some of these edge AI initiatives. So I would start with those, and maybe I'll let others start.
So I was going to go, Saurabh, I was going to go to SaaS3, right? So because SaaS3 went from a different point of view, right? He started at the IoT and the device level, and and now he's kind of building this, or he already has this edge AI, investment. And so the question, same thing, SaaS3 is how difficult, what were the drivers, right? And how difficult it is to actually get it done.
Yeah, absolutely. So some of the drivers that Saurabh described are still valid, which is obviously latency, security aspects of it. The other aspects include, for example, the connectivity. Especially we started off providing these solutions for industrial customers, all the big manufacturing, oil and gas types of customers. And from where those plants are, connectivity to a cloud environment is almost impossible, next to impossible, right? And imagine that, especially for video and audio and types of sensors, the amount of data that you need to transfer to the cloud is cost prohibitive, right? You do not have that much bandwidth to send all of the raw data into the cloud. And not to mention, as I said, Saurabh has already talked about latency and other issues too. So once we settle on an edge solution, we started off, obviously providing this analytics, machine learning at the edge. But the other two big constraints and challenges you've got is that the compute power at the edge environment is constrained. Unlike in a cloud environment where you have got elastic compute, you can create as much compute, memory, storage as you want, which is not always the case in an edge environment. So then the question is, how do you do this data processing on the live streams of data? Hundreds and hundreds of sensors, sometimes audio, video, acoustic, and sometimes combination of the three. How do you do that? And that's part of the challenge that we had to solve. The second biggest challenge in that vein was also this notion of IT versus OT. Typically, when you are putting this solution in an industrial IoT environment, industrial or not, in general, in an IoT environment, the people who are operating this software or using this software are not necessarily technology savvy. They're not the computer scientists, they're not data scientists, they're not machine learning experts and whatnot. Now the question is, how do they use this software where we can provide some sort of an OT stands for operational technology interface, where they're probably drag and drop the notion of a machine or the notion of a sensor or the notion of a defect that they're trying to look for, things of that nature. And then somehow you then translate all of that into a programming environment behind the scenes, whether it's an event-driven programming, whether it's machine learning, AI, things like that. So that's really what we have to solve in this environment.
And Jags, tell me a little bit, how can you help Saurabh and Sastry in their mission? I mean, what's kind of the secret sauce that you're providing at this point?
Absolutely, thanks, Philippe. So I think Shastri and Saurabh clearly mentioned the problems with data, the amount of data that we generate at the edge, right? And then Shastri clearly mentioned about the compute constraints that we have at the edge. Even the sensor, right? Like if you look at the cascading effect of compute, we have sensors that are operating on a very, very low bandwidth computing all the way up, right? So our technology is about helping these data sets and the data analytics to be done in a deep learning methodology at very, very low power, low compute areas. So we can run like a 2-bit model, AI model that can run on a sensor. So you get only the relevant data streamed up to the next layer, where we could run a 4-bit or an 8-bit processing to filter that data further and then send it up, right? So you can divvy the analytics by layer, and that's what Latent AI provides, right? We provide tools to help these developers shrink their model sizes and run these models in different compute constrained environments.
And Goran, same question. So how do you help our friends at SAS and Foghorn in their mission?
Well, I think some of the others have touched on most of the points, but I mean, what we try to do is to simplify this, and this is, as we already heard, a pretty complex setup, and it involves different types of skill sets. I mean, you have OT people, IT people, and data scientists that needs to be involved, and getting all these people together and working in the same tool and understand what each of them are doing, even though maybe not one of them can do everything, they can at least understand what the others are doing. But getting all these people together and being able to implement something in one tool is what we are trying to do. And then also it's about scale. I mean, it's very easy, but it's easier at least to set up a POC with limited scope, but then putting that into production, and especially at scale, is a completely different story. And that's where we try to come in and help also managing this over time, because I mean, AI models are not static. I mean, you start at one point and then you develop over time, and you need to be able to update and improve on these models. So help you throughout the life cycle of these projects is also an area where we try to
awesome.
help out.
Yeah, great. I mean, I think we've hit on all the points, right? It's all about running at a very, very low cost, very low power, and scaling, right? Which is a big issue. Moving forward in the conversation, where are the early cases of edge AI at this point? In which industry? And can you describe one or two of them, just for people to understand a little bit what's happening?
Sure. I mean, I can start and others can add. So, I mean, we've long heard about predictive maintenance being the killer app for IoT, right? So, I mean, I think there's been a fair bit of chatter, fair bit of projections around it. I mean, at some level, I think it has not taken off to the extent that the promise was, and that is because of some of the challenges that we've just talked about, right? It's the IT OT challenges. It's hard to acquire data, the skill set deficiency, things like that. I think we're getting there, right? I mean, we do have pretty solid use cases going on with customers where predictive maintenance is a big use case theme for their organization. So the focus on assets, process, and safety, I mean, those seem to be the driving area for getting these predictive maintenance initiatives off the ground. So that continues. I think there will be progress in that space. The other area that, at least from a SaaS perspective, that we're seeing a lot of traction is computer vision at the edge. That's more of a technology capability that kind of cuts across a number of verticals. But we see a lot of potential with computer vision, especially as some of these algorithms are getting better and better. So we are able to work with more standard commodity cameras. So there is not a requirement that for you to be able to do computer vision in your environment, that you got to kind of redo your infrastructure, bring more expensive type cameras. We're able to do more with existing camera infrastructure. These could be security cameras, these could be CCTV type of infrastructure. Because if you think about what you can do with this, you can do object detection, you can do object tracking. That allows you to understand objects in your space, that allows you to understand where they are and a time element to it. And once you can combine object, location, and time, I mean, that can drive a number of use cases. So one example that we have going on right now, which is pretty relevant with back to the factory or worker safety in the pandemic scenario, is just being able to understand how well organizations are managing physical distancing and crowding in their workspaces as some of these workspaces begin to open. So we have POCs going on right now with manufacturers, with other companies, where they're trying to use their existing security cameras to detect where people are, how far are they, and how long they've been there, right? And to be able to kind of either alert somebody if something is happening that needs immediate attention, but more importantly, also to build some sort of a pattern over time. That are there certain times of the day, certain days of the week when things are breaking down. So that's just one example, but computer vision is just a key technology that can cut across a number of verticals here.
Yeah, I would add on to that. Obviously, we've got 100+ types of use cases. I will be sitting here all day long describing those. What I want to talk about, at least highlight 2 or 3 use cases. For example, one in the manufacturing environment, predictive maintenance is, of course, is a generic term. But more importantly, for example, Stanley Black & Decker, which is one of our largest customers there, they've got plants across the globe, and they manufacture varieties of things. One such thing they make, for example, is a measuring tape. What happens many a times that when the tape is high-speed tape is being manufactured, sometimes there are extra markings, sometimes there is extra paint, sometimes there is no paint or no markings. As a result of which, what happens is the tape gets manufactured, it goes through probably a human quality measurement aspect of it at some point, and then somebody determines that, oh no, this is bad, and it becomes a scrap. Now, how do you proactively predict it and then reduce that scrap? So a computer vision AI-based solution that we have, they install it in the plant, and then processing at 50 to 60 frames per second in the small compute footprint environment, proactively predicting the specific failure conditions that the manufacturer is interested in, and being able to alert the operator as to when that error occurs, and immediately the operator goes and stops. Better yet, now they're actually trying to automate it to automatically stop the machine where the human being is not even involved, and then do that. So we have many such use cases across big names like Procter & Gamble, GEs of the world. Everybody's using this across the plants. A second use case in an oil and gas industry that is actually pretty common and popular is this notion of emissions monitoring, as an example, right? Yes. So especially in gas and processing and refinement, sometimes either because of a compressor problem or a foaming issue or some other issue, you just have to release the gas and let it go through what is called a oil stack or a flare stack, and as a result of which the gas gets burned. So it has a couple of problems. One is a business problem because you're releasing the gas unnecessarily, losing the value and the money there. Second, which is much more important, is this EPA regulations. You're actually releasing these toxic gases, ethane, methane, butane, propane, into this atmosphere. How do you measure the composition of those gases? Exactly how much are you releasing? What's the size of the flare? What's the size of the smoke? And immediately alert what was actually get to the root cause of the compressor problem and things like that. So very, very popular. Saudi Aramco, one of our investors and large customers, has deployed this. Schlumberger is working with us. In fact, there's another panel going on where they're going to describe that use case. Schlumberger is deploying this. So many customers are deploying that as well. The third one, somewhat similar to what Saurabh talked about, especially the worker safety. In manufacturing, oil and gas, transportation, smart buildings, you name it, any of these environments, people want to know if workers are wearing the appropriate PPE, whether they're wearing the right hard hats, helmet, life vest, shoes, and things like that. And now we can closely monitor if there is a violation, report them, and identify them, integrate into their existing environment, things like that. And with the current COVID situation, we also, for example, one of the things that has become very popular with our solution is the health monitoring aspect. Identifying elevated body temperature simply by using IR, combination of IR and video, to be able to identify if a human being has an elevated temperature, measuring at the tear duct, which is above the nose and between the eyes, by superimposing thermal plus video together in a non-touch, in a touchless way. How to do that? It's become extremely popular as school kids are coming back to school, workforce is coming back to the buildings and things like that. And we have additional modules like cough detection, mask detection, of course, is common, social distancing. It's a number of those things. So basically, lots of use cases starting from condition monitoring, predictive maintenance, failure condition detection, that is helping them to improve the yields, to the safety aspects of it, as well as energy efficiency and management aspects of it as well.
Excellent. Thanks, John. That's an excellent list of use cases, right? So from our perspective, Philippe, we start at the chip level, right? So we are working with a couple of semiconductor companies. One of them, we are enabling visual wake-up words, right? So if a human is present in the frame, then you do certain steps afterwards. Our technology is able to compress this AI model to about 100 kilobytes and run on a forward processor very efficiently. Then we have another customer that's working on wake-up words, right? Just like what you have for Siri or an Alexa, similar to that. We have built a model, or we've helped the customer build a model with our technology that can take about 5 to 6 wake-up words and compress it into 125 kilobytes and process that at a very, very, very low power environment. From an industrial use case perspective, a steel customer is using their existing QA pipeline, and they're running on a 4 processor GPU track, and they are reducing that by almost 75% using our technology. They've got 100 units running, and each unit is running 4 GPU cores. They're reducing it to use just 1 because we are able to do the processing that fast. The other one, Shastri mentioned about the IR use cases for temperature reading. One of our customers is a smart glass manufacturer, and we are using both IR and camera to run that model just on the headset itself. None of the data is going up to the cloud. It's doing the temperature analysis as well as superimposing, similar to what Shastri said. All of that is done right there at the headset, and they can tell whether the person who's got a temperature need to be isolated or to be led through the process.
Interesting. Goran?
Yeah, I can just agree with the previous speakers that vision is definitely the most common use case today for obvious reasons. I mean, it has a huge, there are a lot of use cases that can be covered, and it's also very easy to set up since you don't have to connect into any of the existing infrastructure. It can be set up independently of that. But I also would like to touch on an area where we would like to see more use cases, but still don't for a number of reasons. And that is with our customers, which are primarily in the manufacturing industry. I mean, there is a demand for using AI for anomaly detection, not with vision, but with regular sensor signals, where you have lots of those, and you want to analyze the normal state and learn that automatically, and then detect when you have abnormal behavior. But the challenge there is to develop the models for that. I mean, we are not providing models from Crosser. We provide a platform for executing those models at the edge, but we see a lack of these models being available, and especially for smaller and mid-sized companies that don't have the data science type of resources, it's very hard for them to develop these kind of models, but there is a big need for that type of models. So that's an area where I see going a little bit ahead. Hopefully we will start to see more use cases in that space, but so far it's been primarily in vision that we have been involved in as well. So I just can confirm.
I can just add. I mean, I couldn't agree more, Goran, about the need for almost simplifying some level, even automating the model creation process there, right? So that's an area that we see somewhat of a gap, right? Not every organization is flush with data scientists to be able to do this. not every organization even has assets connected and data available. So even if they had data scientists to be able to develop these models. So we are starting to see a fair bit of unsupervised learning that can come in and help here. So even before you begin to collect data that you can train a model with, can you use some unsupervised techniques to just understand, kind of the base condition of the asset and then begin to report against it? You may not know exactly what is happening or what caused it, but you may know something is not right, something is deviating here. So you may have a little bit of a better head start while you are still collecting your data.
Yeah, I absolutely agree. If I can just say, Goran, you're right on in the sense that we're seeing a lot of use cases for vibration-based anomaly detection, especially if you've got a CNC machine or header machine or pumps, any of that, right? Many times all they've got is a vibration sensor and acoustic sensor. How do you do anomaly detection on that so you can proactively? So we have done a lot of those use cases. They're quite common across manufacturing and oil and gas.
Cool. So I'll add a point to that, right? So we are actually developing a tool that is going to be helping with some of the data science problems. Since we can sit at the sensor level edge, we can get a lot more finer data, and we can analyze that data in a way that it can feed into more of a continuous loop on data science, right? And another example, Philippe, I wanted to add was that we've been talking about edge totally closer towards our data stream. But one of the customers that we're working with, they have a very low power camera. This is a domestic surveillance security camera. They don't have enough processing power, and their entire model is not to do too much processing within the home.
Yep.
Now we're helping them doing a surveillance or object identification on a CDN, which is the closest entry point into the internet. Instead of doing it into the deep core cloud, we are doing it on the CDN, trying to identify if there is a human movement present in their home or not, right? So those are the other use cases that can move a little bit up the edge continuum as well.
That's an interesting point you're making, Jags, and it comes back to one of the points that the panel was making just before about when you look at those type of use case and application, how do you manage where the processing and the storage is happening, right? Is there like one source that is a fix for everything, or do you have to manage kind of where is the process is going to happen, and do you have to adjust to the customer setting in the way? So how much customization do you need to have?
It's going to be use case dependent, right? The way we see it. For example, in a surveillance mode, first you're looking for whether there is humans present in the frame, right? That's your first filter. The second filter is, okay, if there is a human, are they carrying anything in their hands, right? That's the second filter. If they are carrying something in their hand, is that a weapon? Is that a baseball bat? Is that a AK-47, or is that a pistol, or is it a knife, or is it an umbrella, right? Those are so as you go, the different layers is where you're going to be extracting more intelligence out of it. So depending on the context, you can identify different things and customize accordingly.
If I can chime in there, go ahead, Saurabh. Go ahead.
So I think Felipe was talking more about the edge environment itself, right? Where do you deploy what? Like, what's the capability from a compute perspective? So, I think that's a little bit of a continuum, Jax, like you said. It depends on the use case, depends obviously on the existing infrastructure available. But, so we've been trying to simplify from our side that, you can look at almost like a simple, medium, large kind of edge environments. So when I think about it's like a small edge environment, that could be, almost, from our perspective, is a small gateway, potentially an Atom-based gateway. And you're not talking about running computer vision there, but you're talking about, you could be running complex event processing type algorithms there, pattern matching in real time, things like that. And then, you just kind of grow from there, right? So if you have to run computer vision, then, I also see a question in the chat window about inferencing, right? Yes. So to be able to kind of accelerate the inferencing, you are talking about a slightly beefier compute environment. Typically, you're talking about accelerators that needs to be added. So it really, like Jack said, I think it depends on the use case. So if you have a use case that requires acceleration support, you probably need to provision some environment that has acceleration. You cannot just use an existing, let's say.
Saurabh, that's exactly the way I mentioned is like we can run on Atom processor. We can do all of these 3 inferences with our technology on an Atom processor.
Right.
That is the reason you don't need a beefy processor to do some of the inferences that we talked about, right? So yeah, use cases vary, and as you go, the goal is for us is not to use a beefy process, right? Can you run it on a low power processing? That's what we are getting at.
That is certainly the trend we're seeing as well. So the thing is that the types of devices, as all the panelists have mentioned, are very different. Some of our customers run this on the PLC itself. Some of the customers run on an existing asset. Sometimes, for example, if you take a locomotive, the locomotive has an existing computer. They're not going to put one more computer on top, so however big or small that is. So you have to run on the asset itself. In other cases where it's possible, they might install, for example, an IoT gateway like the HP, Dell, some of those IoT gateways they manufacture. Regardless of whether it's a small device, medium device, big device, the thing remains, which is, how do you get the best performance out of the device that you've got? This is where we apply, kind of similar to what Jax was talking about, this notion of edification. We came up with this notion of how do you optimize these models so that they can continue to run, whether it's a software-based acceleration, hardware-based acceleration, things like that in those devices. But one other thing I want to quickly touch on, I know we talked about AI. A lot of the times it's actually not sure everybody understands the term exactly the same way as we all do. Is that so what's really AI part of the edge here when we're talking about? What typically happens is, take a use case. When you go build a machine learning model, say whether it's a supervised, unsupervised, doesn't matter how you do it, you build a machine learning model to do predictive maintenance or failure condition detection on some asset, whether it's a CNC machine, pump, whatever you're talking about. Perfect, it's producing, inferencing, producing the result, that's great. Just like everything else in life, the model begins to drift. Because of the changes in the data patterns, because of the changes in the external conditions, the environment, that exact same model that once accurately used to predict the results may no longer do that, may begin to drift. Now, the question is, how do you automatically detect that level of degradation, start incrementally self-retraining the model with the current data set that's coming in, and then maintain the level of accuracy? This is what we're calling AI, artificial intelligence at the edge, self-correcting, self-healing model deployments at the edge, where the results continue to be as good as what they originally used to be when you first deployed that. This is a very important aspect to note, not to mention about the buzzwords, but just this is how at least we are telling customers that this is not a buzzword. This has got practical importance on how it matters to them.
Excellent.
Any other comment on that topic? No. So, I mean, before moving on to more questions around ecosystems, there was one last question on the chat session about waste in the electronics life cycle. And did any of you has experience with edge AI involved to reduce waste? And if yes, is it in the electronics, and can it help reduce the impact of on GHG emissions?
Yeah, I can speak first. We have done lots of use cases on the waste management aspect. Some in, you could call it maybe electrical, capacitor manufacturing. In some other cases, I already talked about, physical goods like the measurement tapes, the tools and things like that. We've also worked on the electronic systems where when machines produce certain parts and those parts are defective, and obviously you have to throw them away, scrap, waste, however you want to call them. The solutions that we put in place and deployed them is to proactively predict, to say what possible combinations of the conditions taking in the sensor values will lead to that. So that's one type of use case. That is more process-oriented use cases. The second one was more discrete in manufacturing, where you've got a unit, or whether it's electronic, whether it's capacitor. We've done a number of the use cases to do the visual inspection, to eliminate the manual quality inspection, but to do a visual computer vision based inspection, identify early on the potential parts that are coming out to be defective, and then alert the operator to reduce it. Once the part is already produced, obviously you can't do anything about that. The whole idea was to how do you proactively predict it, and we have done a number of the use cases: steel manufacturing, tools manufacturing, electronic components, capacitors, electrical components in power plants, we've done a number of those use cases. And I think the second part of the question, I already talked about emissions monitoring. So the way we do the emissions monitoring is that, as I mentioned, two things. One is the video computer vision to identify based on the color spectrum, for example, based on the heat map and the color spectrum. Second was using spectrometry. You can use spectrometry to identify the color spectrum to which gases are actually there, what emissions are out there. Not every gas is exactly the same. So we identify those composition and the values of that, and then alert the operator to see if it is in fact deleting these greenhouse gases out there. So we got a number of use cases like that.
Excellent. So one other use case on our side from an electronics perspective is that, when you do soldering and, multiple components get soldered and the process is on a high-speed conveyor belt, usually the quality control is done at the very end of the process. And by the time you see, the soldering could be a cap shape or a concave shape things, it could, as they go through the process, that may fall off and the board might become useless. So in the process that we are discussing is doing the high-speed quality assurance as soon as the soldering process is complete and see if all the soldered parts are of same equal quality. If not, discard the board and redo the soldering. So that's one way of we are helping reduce waste from that perspective.
Awesome. So let's move to the concept of ecosystem, right? Because it seems, we've talked a lot about the complexity of those type of solutions, and it seems like it's going to be very difficult for one player to actually build the entire solution. And so I wanted to start with Jags and Goran because they are first at the startups, and then they are lower in the food chain, so they need to think about those questions around ecosystem. So how are you thinking about building your ecosystem around yourself, and then what are the missing gaps that you're seeing in the environment that you think people should be thinking about?
Definitely, I'll start with this, and Goran can continue. So for us, since we go work at the very lowest level of the processor, we started our first partnerships with the semiconductor industry, right? We are working with several DSP, AI accelerators, CPU and GPU companies to help them, help bring certain AI models to run on there. So that's the first layer that we are thinking about. The second layer we're thinking about is the OEM stack. We have several OEMs that are wanting to build AI on the edge, right? Like I think about industrial manufacturers or even consumer electronic companies. They want to build certain AI capabilities on their devices. So we are bringing that to them as well in forms of tools and platforms. The third and the fourth layer where we are seeing a bit more traction is on the industrial side as well as on the telco and CDN space. We are working with system integrators, Philippe. They are looking at a broader set of problems and solving a broader set. And for them, they see that getting to the edge could be a problem with maybe open source tools or certain tools that they have access to. That's where we fit into a perfect groove there, helping them bridge that gap and make their solutions a possibility.
Go on.
Yeah, for us, of course, ecosystems is key. We decided already from the start to focus on one specific piece of the puzzle and be the best on that part, and then integrate with other players to provide a full end-to-end solution. So we are definitely believing in a good ecosystem support and rely on that. And I also think it's something that our customers need as well, because as we already mentioned, these are complex systems and you need help to put this together. Of course, one option is to go to one of the big players and get everything from one player, but maybe that is not exactly what you want, and you want to be able to select exactly what you need, and an ecosystem where you can, for each of the different parts, select different alternatives is probably for many customers the best option. But again, as Jags was mentioning, the system integrators are key here as well, because there needs to, even if you have an ecosystem defined, you need someone to help the customer to put that in place, I think, and that's also why we work a lot with that type of players. So ecosystems are definitely very important for us and for our
and
customers.
so, Sastry, on your, from your viewpoint, so how are you thinking about building your ecosystem, and what are the missing gaps, the place where you think there is a need for more innovation?
Yep. So I mean, I think like Jax and Goran said, I think ecosystem is absolutely critical to the success of IoT initiatives. I mean, if you just look at a standard block diagram that starts with maybe a data producer to the ultimate dashboard that a business consumer may be actually using, I mean, there's just a number of components, and not everybody has everything. So when we started the IoT practice within SaaS, I mean, one of our first things that we did was to put in place an ecosystem program. So the idea was that we wanted to look at a deliberate strategy around ecosystem. So whether it is the hardware partners, the cloud partners, and everybody in between. So we have partners from a technology perspective. So we want to make sure that obviously our technology runs across a number of these technology players. So especially when you're talking about the edge, we work with obviously the leading players in that space all the way up to the cloud. So there's a technology aspect of it, and we are very clear in terms of here is our technology working across the board. But there's also a business go-to-market aspect of it, that we don't have to be the one who's leading the offering to the customer every time, right? If there is an existing solution provider in this space, they have a platform, they have a service, and they just want to kind of embed our capabilities to augment their offering, that's fine. I mean, that is also what an ecosystem brings here, that from a customer perspective, it kind of simplifies the consumption aspect of it, that they're not necessarily thinking of, I'm going to take this from SaaS, this other thing from another player, and trying to bridge it together. They can actually take the offering as it stands from a person, from a player that is the most relevant to be offering that to the market. So that's a very important aspect of it. I mean, that continues to be a growing area for us. I mean, we have a growing ecosystem. So like I said, both from the technology side and go-to-market side, we're very firmly big believers in this.
Yeah, thank you. I'll just quickly chime in. I agree with all of the comments the other panelists have made. You know, as they say, it takes a village to really build the whole solution end to end. We obviously provide a very key aspect of it, which is the software layer for the edge AI and the models themselves as well, in many cases, to run at the software level. We have about 5 or 6 different partner ecosystems to put together. One is, of course, the hardware partner ecosystems. We have lots of them. We work with HP, Dell, Cisco, AD-Link, you name it, right? And many a times, customers may not even buy new hardware, so we have to work with existing. Therefore, the more number of players we work with in that space, the better for the customer. Similarly, we also have industrials, because we are catering our solutions to the industrial space for the most part of it. We have partnerships in many cases, OEM relationship with GE, Honeywell, Bosch, Aramco, numbers of the companies out there. Cloud is another place where, as much as today's conversation is all about edge, cloud has a place for what it is good for. Obviously, if you're building a model, you're training a model, you're doing central persistence for information coming across from all the different locations, things like that, you would still need a central persistence store. You would probably need tools to be able to train them, things like that, which you typically run in a cloud. We have pretty good partnerships and ecosystem with all the major cloud providers. We have joint customers that we go into, AWS, Google, Microsoft, and all of them. And then we have lots of SIs. Of course, we have across the globe, all the big names, global SIs, medium-sized SIs, small SIs. We've actually trained them on our software stack, because we're not going to be able to scale if we have to go to every single customer to implement that solution for them. So these SIs are trained; they are able to take the solutions themselves, take our stack, and then deploy this for customers. And more importantly, the last aspect of the partner ecosystem is the semiconductor manufacturers. Of course, Intel is an investor in us. We very closely work with Intel, NVIDIA, ARM, Xilinx, a number of those guys, to continuously work with them to see how do we optimize our processing further as they're coming out with newer and better version of their chips and things like that. So as you can see, starting from hardware to cloud to industrial OEMs to SIs to hardware chip manufacturers, they all have to plug in to what we're providing, but we're agnostic to any one of them. That's the key here. We're not dependent on any one of them, but we can work with all of them, which is really what our customers
that makes sense. I mean, we are almost at the end of the session, so I have one last question for you around when you're talking to customer, what's the biggest hold up at this point for edge AI? Is it like the lack of skills? Is it kind of the maturity of their IT infrastructure? What is the biggest holdback, do you see?
I'll start maybe. I think we touched upon this earlier, right? Data seems to be the problem, right? Today, all machines are producing data. And the data is actually, the way that we're writing the data is more from a human interpretability perspective, right? We wrote logs, we wrote reports for us to read and for us to understand. But it was never made for the machine to learn from it and do inferencing around it. So I think that shift is happening very slowly. And once that catches up, it will be, I think the transformation will happen quicker.
I think
so I can go next if you want. The two challenges, right? One is, of course, connectivity. As Jax mentioned, many times, most of the times, the sensors always exist. The question is, how do you connect into them? There's lots of protocols. Every single environment has slight custom variation of the protocols and how do you connect into them. And the quality of the data as well. I mean, they call it the dirty data in the industrial term, right? Most of the time, so because the sensors are decades old, sometimes they're not working, sometimes they've got missing values, sometimes they just don't, send the information. The question is, how do you deal with all of that? That's one part of that. The second, more from a business side of it, which is the alignment between IT and OT. Many a times, the question is, who is the decision maker? When somebody wants to deploy such a solution, who is it actually the decision maker? Is it the operator? Is it the OT people? Or is it the guys who have got the budget on the IT side? The answer is not exclusive to either one of them. So most successful scenarios that we've seen where people have deployed our solution is where both parties come together. So that's why when we walk into a customer these days, we always talk about first discuss the pain point and then of course talk about the budget. If any one of those two are not in place, it doesn't matter. You're beating yourself against the wall. That's not going to work. So alignment between IT and OT and addressing and resolving data connectivity issues. And once you get past that, I think your solution works like a jam.
Yeah, I couldn't agree more. I think we also see that as the biggest hurdle. The internal organizational issues is the main hurdle. And then, as I mentioned earlier, the lack of models for especially smaller and mid-sized companies, or lack of skills, if you like, in terms of data science to get this up and running for AI specifically. Those are the two main challenges that we see.
So yeah, I'll just agree that, I think the panelists hit on it, right? So the data, lack of a clear stakeholder who owns the edge implementation, I think continues to be a challenge. And just it's difficult to provision an edge environment, right? I mean, if you wanted to run a workload in the cloud, I mean, provisioning is table stakes now. You can provision and run, but provisioning an edge environment is still pretty hard. I mean, that goes back to the ecosystem discussion that we were having. And that ultimately is responsible for the lack of scale at some level, right? That you can get a POC going maybe in a confined environment, but to be able to truly kind of scale it, because Sastry talked about some of these environments being so diverse, right? You have machines that were put in over several decades that don't have same standards or same operating conditions. So that is a huge challenge from a scale perspective. So that's where I think the ecosystem partnerships help quite a bit. But those would be some of the prohibitors from an edge adoption.
Awesome. Well, it's right at the hour, so we don't have any questions per se as well on the panel. So I think we're gonna stop there. Thank you very much for attending the session, and looking forward to listening to the next. And Jags, Saurabh, Sastry, Goran, great panel with you guys. I mean, I think we covered a lot of ground, and you did that with grace.
Thank you, Philip.
Thank you
for moderating.
Thank you.
Thanks, Jax, Goran, Sastry. Nice to meet you guys.
Bye-bye.
Bye.